It's 117 on Saturday. I went and bought the amp meter, 0 to 15 amp meter. Looks like I probably should have gone for a bigger one just because I imagine I'll be expanding this, given how it's working currently. So you can see it's at 117. It's a blue sky day, no clouds, blue sky every which way. Sun's back on up over here somewhere. Panels are over there. Let's see. It's running really nicely. And if you go this way, now we can just calculate watts, right? So we're at 12 amps. 14 volts at 12 amps. So 12 times 12 would be 144 watts. Add two more 12s. What is that? 156, 168 watts going in. So I'm getting about 168 watts out of the two 100-watt solar panels on the roof. Which is probably why they oversized the inputs for this. That's a 400-watt inverter, but everywhere I've seen solar panels connected up, they actually put up to 500 watts on a 400-watt inverter, or 300 watts on a 200-watt inverter. So I guess that's acceptable. In any case, this is a 400-watt inverter, and it's getting about 170 watts in high sun. So if I get 3 more 100 watts or 2 more 150-watt panels, I should be able to run those all on the same leads coming in and max out that inverter. And my amps will have to be a bigger meter. I'll have to go get a 0 to 50 amp DC meter, and so I can calculate the power coming in. It's 12 gauge wire all the way through, and it's the solar panel rated wire, this black wire, 600 volts. It's thick, single wire and single insulation. Anyway, it's running, and 170 watts back in. Today is nice and sunny, right? And it's warm, but it's not hot. It's got a fan on top. It's supposed to be mounted exactly this way so that it can draw the air through the bottom and push it out the top to aid in the convection process for the cooling. So, not bad. Now I know actually what's coming in at a given time. It's hard to tell just from a circle of lights how many watts or amps and volts you're getting, which would make your watts coming off the panels. So now we just know, plain and simple DC. Cool.